My name is Teck. I'm actually from Gnosis Chain, but more accurately, I'm from Gnosis Builders, which is an organization that was funded by the Gnosis DAO to help, grow the ecosystem of the Gnosis Chain. So caveat to this talk, I wasn't aware I was giving a talk until I was in an Uber over here. So I basically took an internal doc I wrote, I don't know, a month ago and made it public. I don't think there's any proprietary information here. There's an internal doc to kind of, as a message to the team to kind of pivot them to doing something new for the next few quarters. So I'm not sure if anyone here was here for the Stefan's talk, but one of our main mission and our kind of aspiration is to become the most decentralized blockchain in the market, and we want to have the most resilient block space there is. So I'll just go through this document. You don't have to read it, and I could just go through it verbally. So the first step to kind of achieve decentralization is to be able to measure it. How many of you have heard of the Nakamoto coefficient? Okay, not as many as thought would have heard of it, but this is a quantitative measure of decentralization that was, I think Balaji and Leland came up with it many years ago as a way to kind of have one number that tells you, easily tell you how effectively decentralized your system is. So in summary, what it does is that it surveys all what they call the subsystems of a decentralized system. For example, written here in this doc, validator node network, the client software, all the client node software, the number of GitHub committers on the GitHub repo, the number of exchanges that have listed your token, which affects the liquidity of your token, and many, many other subsystems you can think of that would make up that decentralized system. And you take the minimum number of entities that needed to co-opt the network or to compromise the network, and that number is the Nakamoto coefficient, right? So very easily, if you think about an adversary or a natural kind of failure, what's the minimum number of things that would fail that would, kind of have your network or your decentralized system not work anymore? So that's the Nakamoto coefficient. And we restricted the scope of our kind of effort for the next few quarters to just the validator subsystem. Of course, there's many others, like I said, above. So just looking at the validation subsystem, it's already kind of complicated because if you think about just the validator node count in a lot of these dashboards out there is not an accurate measure of representation of the coefficient or decentralization because it has all kinds of dependencies below it when you run a validator. And all these could be compromised together, right? So for the purpose of measuring real decentralization, we kind of introduced the concept of correlated validator, which is kind of like the other way of thinking about when E2.0 slashing, they slash correlated validators more so than uncorrelated validation failures, right? So we come with this concept of correlated validator sets. Essentially, it's just validators that are correlated according to some dimension. So some examples of that is, how do you advance here? Hang on, back. So for example, the last sentence here, validators run by the same Unix process. So you run a dApp node, you buy Intel NUC machine, you could run as many validators in that same machine, potentially under the same Unix process. And that Unix process gets killed and then all validators are down. So that's considered one count of a correlated validator set. And then these are the other examples. There are a lot more than what is listed here. Like for example, the one that everybody's talking about is validators that are delegate pools, right? Like Lido and stuff like that, where people delegate their tokens to a service that helps you, earn extra liquid staking services, for example. We consider that as like one instead of the number of validators that being delegated to them. Values running from one IP address could signal that, you could be running from one machine, that machine can fail, and then all values within the machine fail at the same time. So failures don't have to be malicious, right? It could be just a natural fault. So these are other examples. So the next section is something we want to improve on. So in the Ethereum ecosystem, you have a ton of dashboards. I'm not sure how many of these are actively, being looked at or people monitor these things, but these are some of the popular ones. We are building more to inject more useful metrics to kind of measure real decentralization, at least for the Gnosis Chain and potentially for Ethereum as well. Yeah. So next, how do we, once we measure decentralization through the coefficient, how do we actually increase the coefficient? So that's the next problem. So like I said, the coefficient is a simple function of 51% of the uncorrelated validator nodes, right? Because it takes 51%, you need to take over 51% of validators to take over the network. And one of the things we need to understand is that there are a lot of market forces centralizing the validator network because of economies of scale. There's no essentially built-in tokenomic incentive mechanism to increase the Nakamoto coefficient, which is, kind of why we see, all these, validator pools and people delegating to one entity to run their validation services. So, yeah, besides like people kind of, calling this out on Twitter, a lot these days, but it hasn't improved. In fact, it's worsened, right? And that is part of the reason why, the reason why is because decentralization isn't something that's incentive compatible with, the proof of stake protocol right now. So how do we kind of have a sustainable way to have a decentralized network, right? How do we increase the decentralization versus just defending against centralization, which is what I think a lot of projects are doing right now. They're defending the network from getting more centralized instead of increasing the decentralization. So one thing to recognize is that, the incentive to decentralize is external to the protocol, external to the validation system. And that also means that the incentive to increase decentralization has to be injected into the network by a third party. So, for example, like Gnosis Builders as an entity would have the design programs to compel, to incentivize validators to increase the Nakamoto coefficient by paying attention to correlations in their validators, right? When you run a validator, you want to make sure they're as uncorrelated as possible according to all these dimensions that we mentioned. And then, because we have we're delegated with the mission to decentralize, of course, we have to spend a bunch of money to incentivize decentralization. Where do we kind of get that back, right? What's the ROI of that effort? So there has to be a demand for that decentralization. If we have decentralization and nobody cares, then that value cycle just breaks. So that's where the next section comes in, where we need to actually look for decentralized apps that actually care about decentralization. And one thing to recognize also is that, and it's something that's been around since the Bitcoin days, where a lot of new L1s and L2s and, not L2s, but a lot of new chains have come up. And Stefan has mentioned this through the trilemma diagram, where they sacrifice decentralization, sacrifice certain things to optimize for throughput. And that's really because the market doesn't care for it. And this is a phenomenon commonly known as boiling frog syndrome, sometimes called the creeping normality, where it's kind of like, if you think about traffic, right? You know that at rush hour, traffic is going to be bad, but still, you know, no matter what you do, people still, drive during rush hour. There's a kind of tragedy of commons there. So essentially, what this is saying is that you don't care about decentralization until you need it, until it's too late. And also, one other thing to recognize is that decentralized systems or centralized systems, by definition, are just decentralized systems with one node, except you have to trust that node. So by definition, centralized systems are strictly better than decentralized systems in every other way other than trust, right? So if you don't have loss of trust, centralized systems will always perform better than decentralized systems in every aspect. So that's another kind of force that's like kind of preventing decentralization from increasing, and centralization from or decentralization from increasing, and it's a centralizing force where if you don't care about trustlessness, then you tend to use more and more centralized systems because they're better in every other way. So product market fit for decentralization, is what essentially I feel is what we're working towards. But at the same time, we don't have enough failures in centralized systems to see mass adoption. But, I think a lot of us live in countries where there's not failures, and some other places there are failures enough that crypto has gained somewhat of a mass adoption. And some of these are examples of that. I didn't write this document, for this presentation, so like some of these examples are maybe relevant to where we are, but may not be as well. So as a store value, you need, once you start losing value of hyperinflated fiat currency, you also understand that you need, something that is unassailable store value, and that's kind of guarded by decentralization, right? In cross-border remittance, essentially, some of the cross-border remittance pathways are really expensive, 20 to 30%, of the amount of money you're trying to transmit over, and that's a rent-seeking behavior. It shouldn't be that expensive, and crypto, in certain countries are adopting crypto at a very, it is basically replacing the traditional ways to do remittance. CeFi, I feel is great, rapidly being disrupted by DeFi for those reasons, because it self-regulates, it's global liquidity by definition, open access, where CeFi is by definition siloed access, or not open access and siloed liquidity. There are other examples that are not really related to blockchain, but they are failures in markets, right? Failures in something. Sci-Hub is one where there's monopoly in the scientific journal market, and then privacy, as we all know, Tornado was being sanctioned unfairly and censored, and there could be potentially more and more coming up. So these are the use cases that would totally need resilient block space and would appreciate it and would seek out decentralization. Not sure how much time we have, but that's the end of the document. If we have more time, we can take questions, but. All right.